Hey, what's going on, guys? In this video we are going to see how to prove this proposition. Here this proposition says for all x belongs to real number if for all a belongs to 0 to infinity, x is less than or equal to a, then x is less than or equal to 0. Now here we are going to do the proof by contraposition. Contraposition is basically we take the negation of this one and put it right here, and we take the negation of the things that comes after if and put it after then. So we just negate and switch it. So the contrapositive statement of this one, contrapositive, it's going to look like this. For all x belongs to real number, because until if it's going to be the same. So for all x belongs to real number if, and then we have to negate this one. The negation of this one is x is greater than 0. Then we have to put the whole thing. So if it's for all a, it means there exists a, if we negate this one, there exists an a belongs to 0 to infinity, such that the negation of this one is going to be x is greater than a. Okay, here the claim is the one that comes after then. We have to use the first one to prove this one. Now we know that, so here what we do, we let x belongs to a real number, and also we assume x is greater than 0, and let's put a is equal to x divided by 2. And here what we are going to do, we are going to, so we know that x is greater than 0. So if x is greater than 0, we can also write it as 0 is less than x. And then we know that if 0 is less than x, then 0 must be less than x by 2 too, because if x is a positive number, x by 2 should be also a positive number. Okay, so we have this one, therefore we can say 0 is less than a, because we took a as x divided by 2. Okay, so here we have 0 is less than a. Now we have got this one, and it means a belongs to 0 to infinity. A belongs to 0 to infinity because a is a positive number, because it's greater than 0. Okay, so it's between 0 to infinity. So, and also we know that since 1 is less than 2, we can say if we multiply both sides by x, we can say x is less than 2x. So if we rearrange this one, this is going to be x by 2 is less than x, and we know that x by 2 is equal to a. From here, x by 2 is equal to a, we can say a is less than x. A is less than x. So we have this one. So if, and we know that if 0 is less than x, then there exists an a such that belongs to 0 to infinity, such that a is less than x. This is what we want to prove. We want to prove that contrapositive, if the contrapositive is proved, it means the statement also proved, because contrapositive and the original statement always mean the same thing. So if we can prove the contrapositive, it means we also prove the original statement, and that's how we do that. I hope this helps. Thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.